So we humble ourselves to our prayer. Father King of Glory, Father King of Glory, thank you for today. Thank you for the gift of life. Thank you for the gift of this lesson. Thank you for the gift of everyone. Thank you for the gift of our parents, teachers, schools, school fees, Father King of Glory. Thank you for the gift of wisdom, knowledge, and understanding. Thank you for the gift of waking up to attend this lesson today. Father King of Glory, please may our sufferings and Father King of Glory just come into something nice, Father. Some of us have given sleep, some of us have given us all what we need for what we want, Father King. And what we want is to achieve good seeds, Father King of Glory. Everyone here has their own expectations of getting A's, 6 A's, and what an aim, Father King. And everyone has theirs. Father, please make it for me, because without you, nothing is possible. Bless us and bless everyone here. Give us the gift of wisdom, knowledge, understanding. And Father King, let us revise at least what will come, Father King. At least 19% of what is coming. Please guide us throughout this lesson, from the beginning to the end. Some of us, this is our last lesson, but please bless the teacher and bless the rest who are going to stay, and bless us who are going to school tomorrow or today, Father King of Glory. Till that day will come, be with us and guide it. Oh, Father, some of us are scared, but be with us and guide us. Bless our teacher again and again. Jesus' name I prayed. Amen.
Amen. Thank you so much, Marita, for the word of prayer. Today, our major area of focus is going to be on bases. We are going to rotate around HCF and LCM. Like I think yesterday, someone said we need to look at those areas. So we are going to look at those areas for our discussion today. So that is where we are going to concentrate mainly in those areas. Now, when they talk about number bases, we are looking at how we can write different numbers of digits. Now, in number bases, there are things that we need to know under number bases. And these ones are going to be very crucial for you. Number one, we need to know what we call numerals. Now, numerals are like the digits that we write these bases have. And we know very that we have base 2, base 3, base 4, base 5, 6, base 10, base 11, base 12, up to base 16. Now, when you are writing anything in base 2, here we expect that the numerals you are going to write are going to be 0 and 1. Meaning that anything in base 2 has the digits here. An example can be 1, 0, 1, 1, 0, 1, something like that. So you can't have any digit above a 2 in that particular base. When you are talking about base 3, that means you can have 0, 1, and 2. An example of a number can be 2, 1, can be 1, 1, can be 1, 2. So you can't have anything above 3 whenever we are in those particular bases. So sometimes when the question tells that in a base less than 2 or with numerals less than 2. So when they say numerals less than 2, you know that less than 2, that means it can be 0, it can be 1. So that means that it should click very quickly that when they tell that the numerals are less than 2, it means that that is automatically written in base 2, or the question wants you to operate in base 2. When they tell that in the numerals less than or equal to 3, it means that anything with a 3 now must be base 4. So you need to look at these numerals in these particular bases to determine under which base they have written your number. So you look at the numerals within the base, and for any particular base, the numerals through which you write those numbers cannot exceed that particular base. Now when it comes to 10, it is okay. You know you have your 0, 1, 2, 3, 4, 5, 6, 7 up to 9. When it comes to 11, this is where now I want you to pay attention, because 11 can come from 0, it goes to 1, it goes to 2, 3, 4, 5, 6, 7, 8, 9. Now, when it comes to 11, one of the letters they use is T. When they use T, T stands for 11. Some books may use A, capital A. Some books may use small a. But if you meet a question where they have used T and they have not defined what it means that T will always stand for 10. In case we're in base 12, they go up to here for base 12, they will go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When they reach 10, they can use T. Then when they reach 11, they use the letter E. So E will stand for 11. In case they don't use E, sometimes they can use B to mean 11. So you need to, more so if they don't use 11, they will go on and define that where B stands for 11. So, but whenever you meet a question where they have not specified whether it is 10, whether it is 11, and they have used T and E, what has to come into your mind that T will stand for 10, E will stand for 11. Kindly let me know whether we are on the same page. That when it comes to the number bases. Pay attention because like I saw a certain mock where they used T and they used the E. So that one you had to know that T means 10 and E stands for 11. Other letters that they use, let me say A, B, C, D, and the rest of that, those ones they have to go on and define them, what they mean. Whether it is 10, whether it is 11. That's when it comes to those particular letters. Okay, let me hope that is now very fine when it comes to number bases. Number 2, it's going to come when we are converting these bases from one base to another. I want everyone to get your calc. When we are converting bases, let me say you want to write it in base 6, you want to write it in this base. We know very well that we use the BNR, the base, the number, and then the remainder. Now, always what you have to do, take an example, you are converting to base 2. And here you have, let me say you want to convert something like 11. I want us to get our calculators. Now, sometimes when the digits are small, it may be very easy for you to find the remainder. But when the digits are big, sometimes we get challenges with finding the remainders. So I want you to place on your calculator 11. Let me use this pen here. 11, let me use green. You place 11 divided by 2 on your calculator. So place it 11 divided by 2. So on your calculator, you're going to get 5.5. Now, how do you get the remainder? I want you to look here on your calculator. Here there is shift on your left. Here there is something like X, then there is a power there, then there is a button of AB/C. Now this button here is the one that you place after placing 11 divided by 2 and you get your answers 5.5. Place this button AB/C. Once you place it, it's going to give you 5, it's going to give you 1, it's going to give you 2, something like that. Now, what you always need to do is that you have to ensure that this last digit here represents your base, always represents your base. This one in the middle represents your remainder. And this one here represents the number you have obtained. So when I come here to write, I'm going to come here and I write that my number now, when I divide, I'll get 5. My remainder is 1. Then after again, I go on and divide. So still I do the same thing. Now I will say now 5 divided by 2. When you place on your calculator 5 divided by 2, your calc is going to give you 2.5. Place this button again. So when you place it, you'll get 2, then you get 1, you get 2. So I've told that this one, always ensure that it is the same like your base. So it will be 2. Here in the middle, you'll have your remainder. So here I will come, I write here that my remainder is 1, but I've got my answer as 2. Since we are in base 2, we continue dividing until this last digit is below or is lower than your base. So here, when you place, you'll get 1 and then the remainder is going to be 0 because 2 divided by 2, you get 1 remainder 0. Okay, let me first speak on the hand. Yes, Milton.
Yes, good morning, sir.
Morning.
Some of us will use these programmable ones. We don't have the scientific ones. So which button do we place?
For that one, you check. I don't know how your calc looks like, but you check whether it has something like this. S equals to D. Does it have something like that? And for
No,
it, like, if it is here, that one should be around here. Does it have a green button, the one you are using?
no, it doesn't have.
Eh,
This carry for 5,000.
for?
This one
I don't
for
know.
5K.
I can't tell how that calc looks like, but if you can share a photo in the here in the chat, then I can look at it and see whether it has.
Okay, let me share it.
Share here, not on WhatsApp, but here on Zoom. Then I can look at it.
It's okay,
Okay.
sir.
Okay, so after you come here, members, and then you say that now my number 11 in base 2 is going to be 1, 0, 1, 1, base 2. Hope we are on the same page. Members, are we on the same page now on converting bases? I'm going to give another example, but is that fine? Okay. People have said yes. Okay. I want to give another example in the same caliber, such that we can try it out. Okay. Another one. Another
Sir,
one can, yes.
sir, I've shared it.
Okay. Let me look at it. Oh, now this one doesn't have that. That this one of yours doesn't have it. So I am going to advise that you get a calc that can do it. This one will not have it.
Okay, sir. Thank you.
Okay. Okay. Then we are going to go to the second part. I don't know why this. To the second part. Now sometimes, let me say, they may give you a very big number. Let me say they have given you 177 and they want you to do this in base, let me say base 6. That's what you are converting. Now, always what we do, we are going to divide. Go on your calculator, never fear. However big the number is, say 177 divided by base 6. So you divide. Now, once you divide on your calculator, we shall get 29.5. Place your calc. Then after, go on this button AB/C. So you'll get your answer. Now, this is why I want you to pay attention. You'll get 29, 1, and 2. Now, I've told you this one here, here should resemble your base. If this digit here doesn't resemble your base, please, this one in the middle is not your remainder. Pay attention to that. But this number here, we can write it as 29, 1 out of 2. Now, what you have to ensure is how can you make this number here, your denominator, resemble exactly your base of 6. What can we do to that number such that we get exactly the 6? Can someone tell us in the chat? What can we do to that 2 to make it resemble 6 without changing our answer? Can people tell us in the chat? What do you think we can do? There is some operation we can make and we make that number look exactly the same. Anyone? You can type in the chat. Aha, very good, Kathy, Tricia, yes. So what we have to do, we have to multiply it times 3. Yes, so you multiply this by 3, multiply this number up by 3, such that now we can get 29. 1 times 3 is 3, divided by 6. Now, the moment you do that, it means that now this one, as long as the one down resembles exactly your base, then that means this number is going to be your remainder. So I'm going to come here and I write comfortably that this is 29 and my remainder is 3. Members, have we picked that in the chat? Is that okay to everyone, what we have done? Okay. Yes, very good. If now it is okay, we continue. We divide by 6 again. So we get our 29 divided by 6. So when I get, I'm going to get another one. When I get now 29 divided by 6, I'm getting 4.8333. So we put it in the other form or ABC. So here I'll get 4, 5, 6. Do not forget this is the same as 4, 5 out of 6. So since the downer number resembles our base, then 5 is the remainder. So here I'll come and I say 5 is our remainder. And here I've got my answer as 4. Now the moment you reach that the digit you are getting here is less than your base, then that's where you stop. The moment you stop now, you'll say that your 177 is the same as 453 base 6. Yes, if you have a question, better we ask now. How do we know the number we are multiplying with? So one of the easiest way to do it, let me say if you have got 29 and a half, and what the base you are dealing with is 6. So what you do, you get this number down here, you divide it by 2. So your answer is 3. So you know that you have to multiply here by 3, I multiply here by 3. So the calculator for it reduces it. In case I had, let me say, 32 and I had 1 out of 5. But let me say, no, let me use which one is possible. Let me say I had 4 here. And the base I'm dealing with is 12. What I do, I say 12 divide by this 4 down, I'll get 3. So here I multiply by 3, up I multiply by 3. Let me hope, Shalom, it is okay now. Okay, good. So that is what we do, members. Let me give you another bigger one, such that we also test it. What if it is bigger than this? Let me say, you can meet a scenario whereby they have given you one, I'm just creating a number, a bigger one, and you are taking it to base, maybe base 16. That's where you are dealing with. What you do, still do not fear, for you just look, as long as you have your calculator, say 1661 divided by base 16. So you put it in your calc, divide by base 16. So the answer you are going to get on your calc is going to be 103.6 0.8125. Take it in that form, you'll get your answer as 113, 13 out of 16. So that means that here, your remainder is going to be 13. Now, for such a case, I'm going to first write, then I will show you how we are going to define them. So here, I'm going to come, I write 103. I continue dividing by 16. So 103 divided by 16, I'll end up with, here, I'm going to end up with 6 and then 7. Because you get 103 divided by 16, you will get 6, 7, and 16. And we have said the moment you get a number below your base, then it means you are going you are going to write it, you are going to stop at that point. But remember, here, when we are writing bases, we can't write 13. So here you are going to define. Remember, we have used T for 11, for 10. We have used E for 11. Now, for when it comes to A, you can use A to mean 12. You can use B to mean 13. In some books, when you find A being 10, B being 11, C being 12, then D can equal to 13. Now, for this one here, you define what it is. So you say 1661 is the same as, remember we go to this, so you can say the same as 6, 7. Now 13, you replace it with B here, and you say 67B base 16 here. Then after you define and say where B is equal to 13. In case you have used D, then for you say 6ZD base 16, where D represents 13. But don't write here 13 as it is. Yeah. Is that okay? Everyone now? Now, I've said if you find that the last digit is the same, then you continue dividing. You continue dividing until it is less than. When it is equal to that, then you continue dividing. Yeah, I think we did a scenario of that nature. The moment you find those who are around, we said, I think you saw here, the moment the digit is the same as this one, continue dividing. 1 remainder 0. Yeah, okay. Hope now that no, in we don't write 2 digits. The moment you reach from base 11 onwards, we don't write digits. See, 13, we have a numeral of 13 in base 16, but in 13, we represent it using letters, alphabetic letters, Josh. If you were around, I told you when we are writing numerals from 11 onwards, we don't have 10, we don't have 11, we don't have 12 and 13, but we have them represented as letters. Yes. Yeah. So let me hope that is very, very fine. So that is how we do it when it comes to those big numbers. Even if here you had gotten, let me give one example in that nature, because now I think we need to look at one more. Let me say they have given you 1081 and they want you to put it in base, maybe base 12. Like that. Still you do the same. Come say 1081 divided by base 12. 1081 divided by base 12. So here you get your answer as 90.0833. Then we have said place that button of AB/C on your calc. So you end up with 91 and 12. So here we shall put 90 and then the remainder is 1. So you continue dividing. 90 divided by 12. So 90 divided by 12, you end up with 7.5. So 7.5, this is now where I want you to take note of. 7.5 will give you 7 whole number, 1 out of 2. But you notice that this 2 here doesn't resemble the total of, so you ask yourself, what numeral are you going to do? What are you going to multiply with? So may I ask Shalom, if Shalom, you can be the first to tell us what you are going to multiply with. Shalom, if you can type quickly and tell what are we going to multiply with. But the rest, please also type in the chat. What are we going to multiply with? Aha, thank you, Dan. Josh, where are you getting 8? Aha, thank you, Shalom. Aha, yes. Now we have said, you ask yourself, these two here must transform to become 12. So get this base you are dividing. Say 12, divide by 2, you get 6. So that means that here, down, this number you have obtained, you are going to multiply down here by 6, multiply up by 6, such that you get 7, 6 or number out of 12. So that means that your remainder is 6. So I'm going to come and say here, when I say by 12, here I'm getting my remainder, I'm getting here my answer is 7, and the remainder is 6. So then after, since this number is below the base, we stop at that point and then write 761 base 12. But I also want to bring it to your attention. Sometimes they can just put a 12 here. When you find a number 761 base 12, here, this one represents a base here. Sometimes they may not write the word 12 and they just put there 761 12. So you pay attention to that as well. Okay. Okay. So let me hope that is very fine to everyone. Now, sometimes they can as well give you in words. Sometimes they can use some words. So you need also to be very careful with the words they use. Take an example. I saw in one of the papers whereby they were using the word trinale. Sometimes I have seen, I think in that mock paper I saw they wrote it as like this. So when trinary, now it comes tree. Tree means a three. When you see quarter, what has to come to your mind? That it's something that is divided into 4. So that means should be 4. Then you know quinary, that is base 5. When you see sexmo, that is base 6. Septimo, base 7. Now octo, 8. Nonagon. You can also get it from those figures. A nonagon means a figure with the 9 sides. An octagon, the one with 8. Septimo is figure with the 7. Decimal, that is 10. Duodecimal, that is 12. Then 16 is hexadecimal. Now, these are some of the common ones that we can use in daily life. 16 can be asked, more so when the question is about navigation. 16 is used mainly in the navigation. So when they say hexadecimal, you need to know that that is base 16, because they can give you the scenario and they say the bear, he was operating in an hexadecimal base. Mean that if you don't know that hexadecimal means base 16, then you are going to be off track. So also please make sure that you pay attention to the different words that they can use to mean those bases. So that is also very important. Yes, I think it was Beko where they used ternary. But that one is still, if they use ternary or trinary, that means three. That means that is base 3. So you just pay attention to it. Yeah, hope that is very, very fine. Kindly let me know through the chat whether we are good on that. So is that fine to everyone? Because they can use any, so you need to know now the words, the meaning, that these are the words they use and the rest of that. Yeah. So when they use tenale, but this one, it is supposed to be like this, in case they use that tenale. It is written like that. So sometimes if they use trinale or tenale, they mean the same things. So let it not confuse you when it comes to base 3. Okay, I think we are good to continue. Some may have more than one name. Okay, good. Yeah, so we need to remember such that we are not caught off guard in case something of that nature comes. Thank you, Marita, thank you, Marita, for the reminder. Okay, Now we are going to continue. So that is briefly about bases. Okay, we can now start. Our first item is here. They are telling us that our first item is here. We are going to first deal with number bases. Your guardian had money on her account. At the start of the term, he instructed your older brother to withdraw the money to cater for your school fees and other school needs. He gave him an ATM pin written as 97 in base 10. Remember, in base 10, now you need to know that in base 10, we have numerals from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is true for base 10. So the two digits written was 9, 7. But each digit actually corresponds to different digits in base 5, which your brother could not identify correctly. Help your brother to determine the actual ATM pin. What does this question now mean? It means that they have given us two things and they want us to convert to base 5. So that means that we must be able to convert the first one and the second one into base 5. That is the meaning, and that's now what we are supposed to do. We are supposed now to convert them into base 5 because that is where the things are. Hope we are on the same page. So what are we going to do? I'm going to come here and say converting, and I want you always pay attention to the order. When they start with 9 and 7, don't change 7, 9. So I'm going to say converting 9 to base 5. So I'm going to come here and I say this is my base, this is my number, and this is my remainder. Now, which base? We are converting to base 5. And what is the number? 9. I go to the calc. Feel free to use your calc. It is yours. 9 divided by 5. Here we have said 9 divided by 5 will give you 1.8 on your calculator. Then look out for this button AB/C. The moment you place it, you'll get 1, 4, and then 5. We say that the moment this number resembles your base, then you're on the right track. This is the base, this is the remainder. So I'm going to come here and I say my remainder here is 4 and I've gotten here 1. The moment this number is below your base, then you stop there and then say now that our 9 is the same as 1, 4 base 5. Then from there, you'll come and say converting 7 to base 5. Then I'll come and say still this is my base number and the remainder. Then this is my number 7 and I'm converting to 5. So feel free, it is your calc. 7 divided by 5. 7 divided by 5, you end up with 1.4. Once you put it in your calculator, you'll get one whole number, 2 and 5. So we say this one is the remainder, then this is the base. The moment you find out that they resemble, then that is very fine. So here I'll put here my remainder as 2 and my number is 1. Since 1 is below 5, I stop there. So I'll come here and say, now my base 7 to base 5 is equal to 1 base 5. Kindly first let me know whether that is very okay to everyone. So, now, very good. That is fine. Now remember, they started with the 9, 7. So that means we are going to write our pin in that form. So 9 is 1, 4. So I write 1, 4, 1, 2, base 5. And this is going to be our pin. So you make your conclusion that my brother the actual ATM pin is 1412 base 5. Hope that is okay to everyone. Mugisa, I explained if they don't resemble, you look out for what number do you multiply up and down to get the same value as your base? I told you I've done, I think, two things. Very good, Dan. No comma is needed because when you are putting the moment now, take an example, Dan. When you do like this, 1, 4, comma, 1, 2, this one is going to be marked wrong because we can't have a pin with a comma. These ones now have exceeded, they have exceeded the number of because now that means that a comma is also part of the pin. So a comma is not part of the pin. Okay. Hope it is okay now. Yeah. What if they don't give me what to divide by? They give me the base. Now, when they give it the other thing, maybe when they use words that in it's hexadecimal base, something like that. Okay. So we are going to continue. We have another one here. They have told us that Alice is supposed to get the money for fees from a mobile money agent using a 4-digit code. For safety reasons, her father gave her the code written as 234 in base 10. And Alice has to convert this code to base 6 to get the actual code. Help Alice to determine the actual code for withdrawing the money from the mobile money agent. Can everyone first try out this? Let everyone first try out this. We have the base, the number, and then the remainder. So can everyone first try it out? But I'm going to call out. Abigail, you prepare, you will take us through this. If you are on. But everyone, you first try it out on your own. And we see whether now we have mastered how to convert. Atrinda Mali, are we on the same page? Okay. Everyone now is trying. So they have told you base 6. So here I expect to have base 6. So let everyone first try. Okay, Danny. Okay, Hunter. Okay, Danny. Danny, can you raise up your hand? Danny. Danny, unmute. I don't know that Dan can unmute. Okay, I think I'm failing to get Danny. Anyone who wants to take us through how you have come up with your answer? Okay. Yes, Marita.
Good morning once again.
Good morning.
So our number was 234 base 10 base 6. So I got 234 divided by 6, which gave me 39, remainder 0.
Good.
So then I got 39 divided by 6, which gave me 6, a whole number, then and a half. As teacher said, I got the 2, which was the last. I divided it by 6, which gave me a 3. So I got 2 times 3, which gave me a 6. Then 1 times 3, which gave me a 3, making it 6, which is a whole number, then 3 and 6. Teacher said the middle one is your remainder. So I took 3 to be the remainder. So it was 3. Like 39 divided by 6 is 6, remainder 3. Then 6 divided by 6 is 1, remainder 0. Which gave me 1030. Moving from down.
Okay. And this is base 6. Okay. Thank you, Marita. That is okay. Then you can make your conclusion that the actual code for withdrawing the money from the mobile money agent is 1030. Yes. So even if you don't put 6, there is no problem, but it is 1030. Yeah. Because you cannot write the 6. Okay. Let me hope that is very fine. Yes, Mary?
So when do we divide and when do we expand? Like for example, when changing from base 10 to maybe base 16, do
Okay.
we subtract, do we divide or we expand?
Now, expanding is when we are taking anything to base 10. Take an example here, Mary. If we have 130 base 6, so for us to take it to base 10, that's when we expand. I don't know that is okay.
Yes, it's okay, but then the bases are below 10. I mean that are higher
Yes?
than 10. For example, 12 for bases higher than 10, like 12,
Mm.
16, what do we do?
The same thing. You do the same thing. You take them back to base
You did
10.
by
No, you
dividing.
expand. No, you expand anything.
Oh,
Okay, I'm not getting your question well, because what I thought you're asking, when do we expand and when do we divide? Then I'm saying that we always divide when we are converting any base from base 10, and always it must be base 10. Take note of that. That any number you are converting to any base must be in base 10. Then you move it from base 10 to any other base. Take an example. If this number here was given to us in maybe a base not 10, then we had to first convert it from that base to base 10, and then that's when we can divide. Is it clear now? Not yet.
what if, what if it's base 16 to base 10?
Base 16 to base 6, yes. So you first convert the base 16. Let me say it was maybe something like this, base 16. Convert this one to base 10. After converting to base 10, the answer you get, you convert it to base 7 by dividing.
You divide 16 to 10.
Okay, I'm not getting you are saying?
Do you divide when you're changing from 16 to 10?
No, when you are 16 to 10, when you are converting anything to base 10, you just expand. Anything,
Oh,
as long
okay.
as you're taking a to base 10, you expand it. Fine? Hey, okay. So hope that is very okay. But I know you are going to see what we are saying. We still have other numbers to do. So here, do not forget to conclude. Okay. Then we have another one here. The grandparents have given the grandchildren their ATM card to withdraw money from their account using a 4-digit PIN in base 5 after converting this. So can we quickly do this as well? Oh, or we can do this as homework. Can we do this later? Is that fine? But what I wanted to bring to your attention, one, I wanted to bring to your attention this, that the moment you find this, please, that means 179 base 10. That is the meaning, So don't get confused. When you dig it here, so don't take it as if it is 17910. It's not a mistake. So it can be written as 179 and they put 10. They can write 179 and they put here 11. So when you find the base written in digits, it is also very okay. Okay, let me hope that one is very fine. Okay, now there is this number that I want us to give attention to. So they told us that a school inter-class competition in which the winning class would receive a prize money that was a value multiple of 10 presented as this. This is the money. Hope you are seeing. This is the money converted to base N, where this senior 4 class managed to win these competitions by answering all the quiz questions in just, now this is the time, where with T trails better than any other class in the competition. Help the class members to determine the amount of the prize money won and discover the number T of the trails taken. Now, the prize money won, this is the prize money that was won. But in order for us to do it, we need to know what was our T. That is the first thing. What was our T? I want you to now to take note, because they told you that convert the T don't mind about T, because they have told that in base 12 T will stand for who can remind us? T and E in bases, they stand for hope people now remember what those ones stand for. Yes. Okay. Okay. Now, the first thing we have to do is to first find out what does the base N they want us to convert this digit to represent. So the first thing you're going to find out is what does that one represent. Number 2, when you look at 8, E, T1 base 12, I want you to remember that in base 12, we said we have numerals running from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we said when you reach 10, we can use T. When we use 11, we can use E. So where T represents 10 and E represents 11. That is the first thing you need to know, that this number that has been written, it is in base 12. So the T and the E you are seeing here represents 10 and represents 11. Are we on the same page, everyone? Is that okay for the first part before we start on the number? That is the first thing I wanted to bring to your attention. Very good. Now, if that is okay, we are going now to start. The first thing we are going to do, in order for us to be able to convert this to a base N, we are going to first deal with this and find out what is the value of N. Now, I'm going to use this space here to find the value of N. So, we'll have 1, 0, 0, 0, 0, 1 base 2 equals to 45 base N. Now, the first thing you always do whenever you have unknown bases, convert everything here to base 10. Convert this base 2 to base 10. Convert this unknown base to base 10. So to convert to base 10, remember you give place values. I'll have 0 here, 1, 2, 3, 4, 5. Do the same. Remember when you're giving place values, always start from the right going to the left. So this will be 0 and 1. Is the place value okay to everyone? How we are giving our place values? Maria, I have not yet seen you. We don't want to leave you. We are now converting. This one means we are converting to base 10. This means we are converting to base 10. The moment you give them place values, it means you are converting something to base 10. That is the first thing we have to do. Now, we continue and do the number. So here it means I'll have 1, the first one times 2 power 5 plus 0 times 2 to power 4 plus 0 times 2 to power 3 plus 0 times 2 to power 2 plus 0 times 2 to power 1 plus 1 times 2 power 0 equals, so this side we shall have 4 times n power 1 plus 5 times n power 0. Now the first bracket here, we have 1 times 2 to power 5. So that one, you know very well from your math, that is the same as 1 times 2 times 2 times 2 times 2 times 2 plus 0 times anything is 0. 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 Plus, now here pay attention. 1 times 2 to power 0. Anything to power 0 is a 1. So we get 1 times 1, which gives us a 1. So here I'll have a 1 equals to any 4 times n power 1. Anything to power 1 is that same thing. So this is 4 times n. So 4 times n, I'll end up, okay, let me first put the 4 times n plus. Now you have 5 times n power 0. We have said anything to power 0 is 1. So this becomes 5 times 1. So here we shall have 5 times 1. Are we still on the same page, members? Are we still on the same page? No one should be left behind. Uh-huh. Uh-huh. People are saying yes. People are saying yes. Okay, good to go. So for the first one, 1 times 2 times 2 times 2 times 2. Here the first one, what are you getting? Which answer do you have? Which answer do you have? Anything to power 1 is that same thing. Anything n power 1 is the same as n. Dan has 32. So here Dan has 32 plus 0 plus 1 is equal to 4 times n, which is 4n plus 5. Let me hope that is okay. Okay. Now from there, this will be 33 equals to 4n plus 5. So now the next thing is to collect like terms. You can take your 5 this side. Since this side is positive, when it comes this side, it becomes negative. So it will be 33 minus 5 will equal to 4n plus 5 minus 5. So 33 minus 5 will give us a 28 equals to 4n. So at this point, divide by 4, divide by 4. And 28 divided by 4 gives us 7. So 7 will equal to n. Yeah. Let me hope that is very fine. Is that okay, members? Hunter, that is okay. Is it fine now? That first part? Okay, Nana has said yes. Yes. Okay, good. So that's how you need to obtain. Now, what does it tell you? Now, it tells you that this number of hours here, we have to convert it to base 7. But when you look at it, it is in base 12. And like I've told you that you cannot convert it to base 12 minus taking it to base 10. So the first thing you do, you have to first take it to base to base 10. And after taking it to base 10, that is when you can now continue and you continue and calculate what that number is. So I'm going to ask Marie, I don't know whether it is Marie. Marie, if you can unmute, I wanted you to be the one to take us through that part of converting that number to base 10. Marie, if you could unmute, if it is well with you. Marie, you can raise up the hand. I wanted you now to first pick this part, that for us to convert to any base we want, we have to first take it to base 10. Marie, are you on? I want to... Oh, Marie, can you unmute? Marie is not unmuting. Okay. Marie, I'm failing to get Marie. Let me test. Okay. Marie, I'm failing to get Marie, but it is okay. So we are going to go and first convert that to base 10. That is the first thing. So I'm going to have 8e t1 base 12. So the first thing we do, first give it the place values 0, 1, 2, and 3. That is the first thing you do. Now, let's give it the place values. After giving the place values, we do the same. So this will be 8 times 12 power 3 plus, we said e times the 12 power 2 plus t times the 12 power 1 plus 1 times the 12 power 0. That is the first thing. Then from there, that's when you can now start your expansion. 8 times the 12 times the 12 times the 12 plus, now here you can substitute what your E is. That E is 11. So I say 11 times 12 times 12. Because we have said E means 11 and T here stands for 10. Then plus 10 times the 12, then plus 1 times any number to power 0 we have said is 1. So can everyone make the computation and you tell us the total you are getting? Everyone make your calculations and then tell us the total you are getting. Okay, looking through the chat, people are getting, according to Maria, is getting 15529. I don't know that Maria, you can unmute. Maria, are you able to unmute? Okay. People are getting 155. Emerson 15. Trisha 15. Okay, good. So here, when you make your computation, people are getting 15529. Very good. So now this is our number converted to that particular base. So here I'm saying it is 13824. Shanaz, that is okay. 12 times 12, which is 1584 plus 120 plus 1. So when you add everything there, that's when you end up with that answer. Now, after getting that answer, remember our base n is base 7. So to get the amount of money, we are going to convert this to base, because they have told you multiple of 10 presented as this converted, that the money was the value multiple of 10 presented as this converted to base n. So we are going to convert our value we have obtained. Now this is base 10. we are going to convert it into base 7. So we are going to come here. I can write here that this is my base number and the remainder. What is my number is 15529 and this is base 7. Can everyone still first convert? Everyone, can we first try on our own? But then someone can raise up the hand after people have tried, and then we start. I don't know. Danny, I don't know whether your microphone is the one that is not working, but I think I failed to get you on mic. So let's convert to base 7 because our n was 7. Okay, can someone raise up the hand? Oh, and someone can raise up the hand and then you take us through. Anyone can raise? Okay, Josh, unmute.
So, good morning, sir.
Yes, good morning, Josh.
So, converting it to base 7,
Mm.
I get, in my calculator, I get 15529 divided by 7.
Okay,
In the calculator, I got 2218 point some values. Then I pressed the other digit you told us. I got 22183 out of 7.
okay,
So my
good.
remainder is 3.
Okay, good.
Then when I divide that 2218 divided by 7, I got 316 6 out of 7. So my remainder is 6.
Okay, good.
Then when I divide 316 divided by 7, I get 45 1 out of 7.
I beg your pardon? When you divide?
316 divided by 7, I get 45 1 out of 7.
Okay,
So my remainder is 1.
okay,
Then 45 divided by 7, I get 6 3 out of 7.
okay,
So my remainder is 3.
okay.
And then since 6 is less than 7, I arrange my number from the bottom, which is 63163 base 7.
Okay, very good.
That's all.
Okay, okay. Now, so here, even if I don't put the 7, because they told that the answer we get here is going to be the amount of money. But when you go back, thank you, Josh. This is correct. When you go back, the question told you, I want you to go back and read. Then they told that they received a prize money that was a value of multiple of 10. Now, this is very key. a multiple of 10. That means that the answer we get must be a multiple of 10 presented as this converted to base n. So now I want you to tell me in this is now the prize money. This is the prize money. Tell me, is it a multiple of 10 in the chat? Is it a multiple of 10? Is it a multiple of 10? No, it is not. Now, can we estimate this amount to a multiple of 10? Can we do our approximation to an amount that is a multiple of 10? So I want us to say now approximately to an amount of 10. To an amount that is a multiple of 10. People have started giving in their suggestions. Good, good. A multiple of 10. But do not have an idea that if it is money in Ugandan shillings, you need to have that kind of mind now. When you are making your approximation, so which one would be the best basing on our Ugandan context? Mugisa, yes. I don't know that Mark, you are getting it. Sharon Mark, hope you are getting it. Search now, this is okay. I don't know that people now are picking. Now, Sharon Mark, when you are approximating and you look at 3616, when this is a 6, remember when you are approximating to the that's what we call the nearest hundreds. This is 0, 1s, and this is a 0, 1s, 10s. When you're approximating this, when you look at this one can be rounded up. So you can add a 1. So this becomes 6, 3, 2, 0, 0 to the nearest. So here, I expect you to round off your amount to this, to the nearest. Such that the money you get is a multiple of 10, but also it is good in our Ugandan context. Has everyone picked the idea? Has everyone picked the idea? Okay, 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 good. Since now hope we are on the same page. Now we can move on to one part. Now we are going to do the second part of that question, though it is not part of this, but we can just do it. Now the second part of this question told us, so that was the prize money, but also they wanted us and discover the number T of the trails taken. Now this second part was testing for our knowledge of indices. That's what it was testing, whether you remember your indices. So that is what the question was testing. So allow me to write here 32 everything power 0.8 plus plus root of 3t plus 2 is equal to 25. So it was testing for your knowledge on indices. That's what it was testing for. Now, when you look at this number, when you are approaching it, whenever you meet these indices number, first express them in form of power and a base. That is the first thing. Take an example. When you have 32, first write it in form of a base and a power. That is the first thing you do. A base and a power. A base and a power. Now, when you get 32, you can say now 32. How can you start with the first one? You say, I don't know whether some of you like using this, others may like to use this. By 2, you say 32 divided by 2 is 16. Then you continue by 2, 8, by 2, 4, by 2, 2. And then after you say 32 is the same as 2 times 2 times 2 times 2 times 2, which gives us 2 power 5. So you can do it that way. So you first express all in this format. So who can tell us 25 in form of a power and a base? What are you getting? In form of a power and a base. Which answer are you getting, members? Or what can it be written to? And remember, the base, your base should either be a 2, it can be a 3, it can be 5, it can be 7. Those digits. Yeah, 5 power 2. Thank you, Danny. So now we are going to approach the question very well. Now, I'm going to start with the first part. So where there is 32, we have said 32 is 2 to power 5. I'll have 2 to power 5, everything 0.8 plus 3 into t plus 2 is equal to 25, which I can first leave as it is, no problem. Now, when I continue here, I want you to remember from your indices that when I have a power m and power n, this means that this is a m times n. That is the meaning. So here we shall have 2, 5 times 0.8 plus 3t plus 2 equals to 25. Now, when it comes here, 5 times 0.8, you can multiply. Feel free to use your calc. 5 times 0.8. So 5 times 0.8, you end up with a 4. Alternatively, someone can say this is 5 times 8 out of 10. Then you say by 5, 1, by 5, 2, by 2, 1, by 2, 4. So here we shall remain with the 2 power 4 plus 3t plus 2 equals to 25. Kindly let me know whether we are on the same page. I want to first reach that stage. Okay. Okay. Maria. um, Now, when you are expressing something in form of a power, in form of a base and a power, like I've told you, always use these odd numbers, 2, 3, 5, 7, 11, those ones. Those are the ones you use. So you say 2 to power this, 3 power this, 5 to power this, 7 power this. Those are the ones we use. Okay, now I'm going to first simplify 2 to power 4. What do you get? 2 to power 4 means 2 times 2 times 2 times 2. Then plus my 3t plus 2 equals to 25. So 2 to power 4, which answer do you have, members? Oh, okay. 16. So this is going to be 16 plus 3t plus 2 equals to 25. Now, why am I leaving 25? I'm leaving 25 because I have noticed, or when you look at the number, you can collect like terms. So I'm going to first collect like terms. So this is going to be 16 minus 16 plus 3t plus 2 equals to 25 minus 16. So this side I remain with the root of 3t plus 2 equals to 25 minus 16. So 25 minus 16 will give us a 9. I don't know whether that is very okay to everyone. Is that okay? Are we there? Are we on the same page? Yes. Now, Sharon Mark, when you reach this step here, collect like terms. So this 16, take it this side. When you take 16 this side, it becomes a negative. So when we take it outside, we get 25 minus 16. So we remain with this. Okay. Let me hope this is very okay. Now here, there are two approaches you can use. In the chart, you tell me, if I want to remove this square root, I want to remove this square root. What can we do to remove the square root? What can you do to remove that square root? In the chat, I want people to tell me. Oh, I can first give you an example. Imagine you have remained with a squared equals to 4. What do you do? Square both sides. Square both sides. Very good. We square both sides. Perfect. So we are going to square both sides. So at this point here, to remove the square root, I will square this side. I will also square this side. So this side, it means that when I square, we shall remain with 3t plus 2 equals to 9 squared. And 9 squared, when you say 9 squared, will give us 81. So this is going to be 81. Yeah, hope we are still on the same page. Hope we are still on the same page. We are not leaving anyone behind. We are not leaving anyone behind. I hope we are not leaving. Now, if we are not leaving anyone behind, kindly can you tell me how can we write 81 in form of a base and a power? Can we write 81 in form of a base and a power? Place your answer in the chat. Write for me 81 in form of a base and a power. Okay. 3 power 4, very good. So here we are going to continue and say this is 3t plus 2 equals to 3 power 4. Now, the moment we reach that point of 3 to power 4, people who don't know, please, you go back and say 81 divide by 3. What do you get? 81 divided by 3 is 27. Then by 3, 9. By 3, 3. Then you know you are going to have 1, 2, 3, 4s. A. So from here, when you reach here, remember that when the bases are the same on both sides, equate the powers. So I'm going to equate the powers that t plus 2 will equal to 4. So I collect like terms by taking the 2 to the other side. So I'll have t equals to 4 minus 2, and therefore our t will equal to 2. Kindly let me know whether that is very fine to everyone. Is that very fine to everyone? Yeah, fine, good. Okay, so then the next thing is for you to make your conclusion, because they asked you and discover the number t of the trails taken. Then you are going to say that trails taken were 2. So you make that conclusion that the trails that were taken were 2. So I don't know which mock paper this number was, but yeah. That is how you had to approach the number. Okay, are we good to continue? Are we good to continue? Okay. Oh, it was sure. Okay, yes. Okay. Yeah, now we continue and look at another thing. Hey, this was another number. I want you to read it through. Now I want you to read through and tell me that now we can be able to do this. First read through. Can everyone be able to do this? And tell me, can everyone be able to do this? Okay, people saying yes, perfect. So that is very good. So you just convert the 31 to base 3. That's what the question was asking. Then we have this one. I don't know which paper was this as well. All these ones I'm displaying a mock, so I don't know I don't remember the mock paper. Read through. Is this you take? I don't know. The person who was talking about you take. Okay, Nana, you have said this is you take thing, eh? Okay, people are reading through. It is okay. People are saying it is okay. If it is okay, can we do it now? I want people to fast. Now, they told that James. Okay, people are saying this was the take. Okay, we can give it some attention. It says that James later forgot his mobile phone's password. He only remembers that the password was generated from the product of his age in base 6 and that of his daughter in base 6. He is 45 years old and the daughter is 12 years old. Now, what does it mean? It means that the first thing you have to do, you have to first convert the 45 to base 6, convert the 12 to base 6, because they told that the pin is a product of their age in base 6. So we are going to say converting James's age to base 6. So we have said we have always the base, we have the number and the remainder. Now, since this is already 45, it means that it is in base, it is in base 10. So shall divide by 6. Can we quickly do? I don't know that someone can quickly take us through this. Anyone who wants to take us quickly through this? Okay, I'm going to just put the answer. Now, this is where the other interesting thing is. This is where the other interesting thing we said. So when you say 45, divide by 6, the answer you get is 7, 1 out of 2. So this is where now you get this number here, the 6. First divide it by this number you're getting down by 2. You get 3. So that means here you multiply by 3, multiply by 3. So here, your remainder is going to be 3, and here you'll end up with 6, 7. So then by 6, you'll get 1, remainder 1. You get 1, remainder 1. So that means that 45 years to base 6 is 1, 1, 3, base 6. I don't know that. Okay, this is the side take. Okay. So this is what you do. Then from there, you are going to convert the 12 years. So also convert the base, the number, and the remainder. Then this was 12 years. Have the 12 years, convert it to base 6. So 12 divided by 6, you get here 2, remainder 0. So that means that this one is going to be automatic. It's going to be our 12 years will be equivalent to 20 base 6. Is that fine to everyone? Is that okay at least how we convert those bases? I'm waiting for people to let me know whether it is okay. That part is very fine. Okay, it is very okay. Now we are going to yeah. Now, how can you know? Now, when we are counting, when we are counting, we count in base 10. So Olive, when someone says 45 years, that is base 10. That one you need to just know that when we are mentioning, when we are counting, when we are doing things, mainly we do in base 10 because it's a common base. Yeah. Unless when it is in a different base, they will state it as well. Yeah. Okay, so from there, so when we are counting the years, year 1, year 2, year 3, we count them in base 10. Year 1, year 2, year 3, year 4, year 5, year 6, 2001, 2000. Yeah, so that is how we count. So that one, when we are counting, is base 10. Okay, so from here we are going to multiply because they have told us that the pin, mobile pin, is a product of the age of the father and the daughter, mobile pin. So we are going to multiply. So I have 113, 20, and now I'm multiplying. And please show. Now, here pay attention. I'll start multiplying 0 times 3. Here, our answer we shall get is 0. I put here 0. I go to the next one. 0, so here is 0. 0 times 1, I'll also get 0. 0 times 1, I'll get 0. So all those three, we shall have 0, we shall have 0. Then we go here to the next one. Now, the next one, we have here 2 times 3. So I'll say 2 times 3. I'll get 6. But remember, always remember that in base 6, remember here we are dealing with base 6. In base 6, we don't have any number of 6. So what you do, you say 6 divided by the base 6. So here you'll get 1, remainder 0. So what do we write? We write our remainder, the 0, we carry the 1. Then when you reach here, you say 2 times 1. So here we shall have the 2 times the 1, which gives us 2. Then we had this number we carried, so we add it there, plus 1. So we end up here with 3. Then here we have 2 times 1, which is 2. So at the end of the day, we end up with 0, 0, 3, 2, because here we end, and this is our pin for that case. Is that fine? Is that okay? Okay, yes. Yes. In case sometimes you are doubting what you have done, now for this case, the other alternative could be to check whether your answer is, you multiply 45 times 12, since we are in base 10, after that, convert that to base 6. You'll get the same answer. Okay. Okay, now pay attention to multiplication. Always write the remainder, carry the other one. Okay. Now, well, I don't know which mock paper was this now again. Which mock paper was this? And that one, the one who was telling us, was it you take what? Kindly, you can take a screenshot and share in the chat, such that we can as well look at it. So here, they told us that a certain member of your family wrote each digit of his 4 digit, pay attention, each digit of his 4 digit card pin. Each digit, remember, if you have your pin, let me say this is my pin. It means that each of these digits, each of them was written from a number system, base 10 to another number system less than 4. Now he is sick in the hospital. He can neither talk nor write, but in a base less than 4. Now bases less than 4 we have base 2, base 3. Those are the only bases less than 4. Hope now we are on the same page. Now he is sick in the hospital. He can neither talk nor write, but the man on his account is needed to finance hospital bills. Here is how he wrote the PIN. Now, the first thing you have to identify, when you look at these digits, you are going to first come back. In base 2, what are the numerals? 0 and 1. In base 3, what are the numerals? 0, 1, and 2. Now, when you look at the two bases, we have to convert our thing. When you look at the digits, the first one was 1, 2, 2, 0, 2, 2, 1, 0. You tell me, when you look at 2, 2, when you are writing base 2, it must stick to the base 0 and 1, but already you are seeing a 2 here. So that means automatically the base 2 is disqualified automatically. Then that means that the only base you are remaining with is base 3, because for it, numerals of 1 and 2 can be written. Members, is that fine? Is that okay to everyone? Perfect, perfect. So that means that here we are going to deal with base 3. Very good. Now, what is your task? Our task is to now to know that which number system do you think he used to rewrite the pin and why? So here, your answer will say that he wrote the pin in base 3 because you look at the numeral. Because the numerals in the digits that he wrote, the highest numeral is 2, which only belongs to base 3. So you reason like that. Then they want us to identify the number system to help your family regenerate the pin. So you are going to get one digit. Don't forget the order. We started with 12, we went to 20, 22, and 10. That means you have to convert each of these digits from base 3 to base 10. So I have 1, 2, this is base 3. So don't forget now that down here, there is an hidden base 3, there is an hidden base 3, there is an hidden base 3, there is an hidden base 3. So we convert them. So we say that to move from any base to base 10, that's when we expand. Marie, that's when we expand. So can everyone start expanding? Me, I'm going to expand 1. Give it the place values 0, 1, and then say this is 1 times 3 power 1 plus 2 times 3 power 0. So this will give us 1 times 3 plus 2 times 1, which will give us here 3 plus 2, which will give us the 5. So can we be doing the rest as well? Also, let's try the rest. Yes, let me hope Shifra, we are on the same page. Maria, hope we are on the same page. Milton, Chisache, Shakespeare, Tisha, Tulina, Josh, Natal, Nathan, Kathy. Hope we are on the same page. No, Mark. No, I've just done for you one. I'm saying, now let's do the rest. This is just for this first one of 1, 2. I want us now to do what about 20 base 3? Then after that, what about 22 base 3? What about the 10 base 3? Remember, these are the digits. This is the first digit, second, third, fourth. I don't know that is clear now. Hunter, yes. Hunter, you can. Hunter, yours is a 3-digit thing. I don't know why. Eh, Hunter. Hunter. Okay. So expand. So still give it the place values 0, 1. And then after you set 2 times 3 power 1 plus 0 times 3 power 0. Okay. So here I'm getting 6. So you also convert. Do the same. Do the same. Do the same here. Give it the place values. Then set 2 times 3 power 1 plus 2 times 3 power 0. So this will be 2 times 3 plus 2 times 1, which is 6 plus 2, which gives us the 8. Do the same here. Have 1 times 3 power 1 plus 0 times 3 power 0. This will give us 1 times 3 plus 0 times 1, which will give us a 3 plus 0, which is 3. I want to see who had the things correct. Hey, Marita. Hey, Danny, that is good. Marita, I don't know where the problem is. Looking through the chat, Maria had a good answer. Tulina had, Shanaz had, Milton had. I don't know. Marita, if you could unmute and tell me where the problem is.
Teacher, my problem is it is always disturbing me. These things of powering, like any number power is this, any number power 0 is this. I just don't understand. Like,
What you do, put it on your calc. Anything that is failing, for you say 2 to power 0 on your calc.
okay, teacher.
Is that fine?
So let me see.
For you put it on the calc.
Okay, teacher, it is 1. 2
Eh,
to power
yes?
2 to power 0
Hmm.
is 1.
1, yes.
So teacher, I just put in my calculator.
For you just be putting in your calculator, anything that you feel is disturbing you, put in the calc, you get the answer.
Thank you, teacher. Maybe something.
Okay. So at the end of that day, please do not, how do I place power, sir? Power, like on your calculator, there is a thing that looks like this on your calculator. I don't know how I can. Look for this thing on your calculator. Like I think on some calculator where you have ABC, you have a root, you have an x squared, there is a thing that looks like this. That is the power. So you first write 5, place this thing, and write is 0. I don't know whether Maria, you have seen it. Maria, you let me know whether that power, you have seen that icon. Okay. Hope Maria. Yes, okay. Yeah. So that is the one you can use. Even if it is power 5, you place it 5 power 5. Even if you have a negative, the only thing I want you to pay attention is when you have negatives. So when you have, let me say, negative 2 to power 3, what you do whenever your digit here is the negative, first put a bracket, negative 2, then you put that thing. You put this one in a bracket, then you put that thing. So here, it means that our pin, don't write it in that order. So it will be 5, 6, 8, 3. That is going to be the pin. Then you conclude that the pin to use to withdraw the fund is 5, 6, 8, 3. Yeah. So let me hope that is very good. Can I assume that now we cannot fail anything concerning number bases? Has everyone picked something that now at least we are confident anything involving number bases, we can be able to crush it? Okay. Very good. Let me first pick on Marita. Yes, Marita.
Teacher, there is this small paper, like we never did it at our school, but I saw it in the group. Like they were like, the pin, the last number is like the first number is times 2, the last number, then the middle number is like that. They never gave us the actual number, so we had to find for ourselves the number.
Oh, was it about say number bases? What?
It was still about this number basis. Then
Okay,
let me see.
if you
Then
can
you had,
trace it, Marita,
yes, teacher.
if you can trace it and you send it here in the chat.
Okay, teacher. Let me look.
Okay. Okay. Now let's start the second concept. The second concept is about highest common factor and the lowest common multiple. Now, when it comes to applications of these two, I want you always to look out for two things. When it comes to highest common factor, here we are looking at dividing. We are looking at sharing. If the question is about sharing, it's about distribution, that I want to distribute things to what. If it is about maybe cutting things in proportions, for you the moment you see any of those words, then it means that the question is indirectly asking you to find the highest common factor. Then, anything with the distribution, you have seen clothes, piece of land. You have seen they want to take items to these quangular things. They want to know how many people they can invite for the party. They want anything with sharing, anything with the distribution. That one, the idea behind is highest common factor. When it comes to lowest common multiple, this one involves things that will happen again. If they ask you that these people are meeting here, when will they meet again? That one is lowest common multiple. And sometimes here, the moment you see things of dates, at any date in the question, just know that the idea rotating behind is LCM. For you read and you see a date somewhere, then what should come to you first is LCM. They're asking, when will they meet again? They last met on this date. For you see date, then what has to come to your mind is LCM. Highest common factor, you are looking at how many people can you invite? What is the largest piece of cloth you can get you when you have this? That is the thing. Then lowest common multiple, you are looking at things that can occur. Maybe people are running, but they want to know at what point will they be at the same point again. Maybe people are they have visited the doctor. They want to know when will they go back. People are, all of those ones are applications concerning multiple. As long as you see happen again, you see the date, then you just know that is lowest common multiple. Kindly let me know whether we are on the same page on those two applications. Are those two applications, have you understood what to do? Aha, very good. Now from there, I want us also to remind ourselves of the dates. Because I'm not seeing that many times we fail the dates. Most when when it is about dates, just know that is about LCM. Now, when you go to your fingers, I want you to use your left hand. When you fold your left hand, this one, on your hand, this one here represents January. So these dates, the way they run, 31. When you come here in this thing here, for February only, you know that is 28 or 29. Then the moment, as long as you are up here on your thing of your fingers, that is always a 31. So you start January, February, March, April, May, June, July. You go back. I don't know whether this picture is familiar to us or we know how to apply it. Kindly look at it and can we practice and now know and know that this is January, February, March, April, May, June, July, August. Then you know that anything up is the 31 day. Then anything down is a 30 apart from February. Will this help you now to remember? Because you need to remember, whenever they mention a month, they say that they last met on the 28th of April. Then you say, over how many days are in April? Then you need to know that April has 30 days. If they say, oh, they last met in May on the 3rd of May, then you need to know that now if it is in May, how many days do we have? Now, to remember the date, the number of days within the different months, this is the thing I'm telling you. Look at your finger. You fold your left hand, then start from the left still. This first one means January. Then then here, like in the Cavalry, there is another month. On top, another month. Down, another month. On top, a month. This one, down. I don't know whether people have practiced it a bit, and we are on the same page, Nathan. Hey, the small finger, your smallest finger here on your hand, that is the one I'm saying. When you fold it, it will represent January. Then in the middle here, it represents February. When you fold it again, it represents. So is it okay to everyone to remember those dates? I want that even if they put the dates, for you can be able to know that this month has 31. You don't need a calendar. Are we together, everyone, on that point? Same page? Nana says yes. Maria says yes. You fold it. The way you see this arm, the way I've put it there is the same way I want you to remember the different months and their number of days within those months. Okay, very good. Very good. Okay, now we can start to do some few numbers here and there. So can you first read through that? Can you first read through that? Read it through. What are you seeing on my screen? What are you seeing on my screen? Are you still seeing the PowerPoint or you are seeing something different? Hey, okay. Sorry, let me share again. Okay, a minute. Okay. Okay, read through. So we are going to do this number together. So we have two people, Muchawe and Gladys. But I want in the chat, you first tell me, which kind of application is this? Is it LSAM? Is it HCF? Put in the chat. Is it HCF? Is it LSAM? LCM. Very good. I love it. I love it. Yeah, they agreed to. So Muchawa and Gladys have an acre of land in Jinja. They agreed to make their payment for the land on the day when they would both be off duty. Muchao is off duty after every 4 days, while the Madame Gladys is off duty every 7 days. They want to know the exact date they will be on off duty together so that they can make the off payment. Now here you say applying or application of LCM. We say the moment has things of meeting again. So now you're going to come and say, you have 4 days, he has 7 days. So you start by 2, 2, 7. By 2, 1, 7. By 7, 1, 1. Then you say now the LCM will equal to 2 times 2 times 7, which will come here to say 2 times 2 times 7, which will equal to 2080 days. That means that they can meet again after 2080 days. Now you go back, you ask yourself, 6th is which month? That 6th, that is the June month. So you go back to your fingers here and ask, what is June? June is here, 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 here. So June has 30 days. So now since June has 30 days and here you have got 28 days, when will they meet again? Very good. Can someone give us the date? Give us the date. When will they meet again? On the 29th. Very good. So I expect you to come here and say they last met on 1st plus the 28th, which is going to be the 29th. So that means, remember, the number of days within June are how many? You know that June has 30. So 30 minus the other day, which will give you the 29. So still, they will be able to meet on the 29th. So you say 29th of June 2025. Hope that is okay. So you just add 1 plus the 28, then you get the 29. So that means they'll be able to meet because June has 30 days. Is that okay to everyone? So here you conclude that the future date when Muchawe and Gladys will be off duty will be the 29th of June 2025. So that's how you conclude. Okay, I can show you another one. Look at this one and tell me which application are we looking at? I've said, okay, when it comes to count, okay, we are still doing other numbers. How to count the, people noticing? Very good, very good. That this is now HCF. So you come here and please do not forget to identify which kind of application is it. So you say application of HCF or applying HCF. So you come here and say you have 120, you have 150, and you have 210. Now, do not forget that always you first ensure that the units are the same. Be it all same, be it the other one. In case this time, in case you are dealing with hours, let everything be in hours. In case you are dealing with minutes, let everything be in minutes. So you make sure that the units are the same for whatever thing you are doing. Okay, so yes, Milton.
Good morning once again, sir.
Good morning.
There's a certain paper Marita has sent in the chat, so I wanted you to go through it because I also wanted to send it and we go through.
Okay, we shall give it time. We shall give it time.
All right.
Okay, so this is the application of HCF. Now, what are you going to do? Remember, when it comes to highest common factor means that number that goes throughout at the same time. It must be able to go through this, and this at the same time. So you start slowly by 2, then you get your calc and say 120 divided by 2, you get 60. 150 by 2, you get 75. 210 by 2, you get 105. Then you can continue. By 2, 60 divided by 2 is 30. 75 by 2 doesn't go through because you get a point. So this will be 75. 105 by 2 doesn't go through because you get a point. Then you continue. You can say by 2 because 30 can still go by 2. You get 15. By 2 doesn't go through, doesn't go through. Then you say, what about now by 3? Then you start 15 by 3 gives us a 5. 75 by 3 gives us a 25. 105 by 3 gives us a 35. You notice that now 3 doesn't go through. Now you continue. By 5 will give you a 1. 25 by 5 gives us a 5. Then 35 by 5 gives us a 7. Now, the moment you reach a point where you have a 1, that means that's where you are going to end. Then you ask yourself, for the first part, did the 2 go through all? 2 went through here, 2 went through here, 2 went through here. You circle it. You come. 2 went here, 2 didn't go through here, 2 didn't go through here. So that one is off. When I go to the next one, 2 went here, 2 didn't go here, 2 didn't go here. You cancel. You go to 3. 3 went here, 3 went here, 3 went here. That means that is okay. You go to 5. 5 went here, 5 went here, 5 went here. You circle it. Now, the moment you meet 1, even if you stop there, but even if you had completed and let me say, you had said by 5 it will be 1, this one is going to be 1, it will be 7. By 7 it will be 1, 1, 1. So here still you come, you say 5, 5 went through here, 5 didn't go here. When you go to 7, 7 it is okay, but it didn't go through these ones here. So as long as you have one part where it doesn't go through, you ignore that. So that means that now we shall come and say that our highest common factor is going to be 2 times 3 times the 5. And when you multiply the 2 times 3 times the 5, you end up with 30 centimeters squared. What does this one mean? Now, this one means that the largest, because they were cutting clothes, it means that the largest piece of cloth that can be made is 30 centimeters squared. So when they ask, find the largest possible size of each small tablecloth that can be cut from the 3 pieces without any waste, then you would say that the largest possible size is 30 centimeters squared. Then the next part wanted us to calculate the total number of tablecloths that can be made from the 3 pieces combined. Now, when you have the 3 pieces, you need to ask, in the 120, how many clothes can you be able to make? In the area of 150, how many pieces can you be able to make? So you can say that number of tablecloth will equal to the total area divided by area of one tablecloth. So you'll come here, you say 120. So you say in 120, let me write here. This is part B. In 120 divide by 30, how many clothes can we be able to obtain? So 120 divided by 30, you'll be able to obtain 4 pieces. Then what about in 150? You say 150 divided by 30, 150 divided by 30, you end up with 5. Then what about the 210? 21 by 30, you'll have 2130 divided by 30, which will end up with 7. But the question wanted to know the total number of tablecloths that you are going to make. So you'll come and say now the total number will equal to 4 plus 5 plus 7. So 4 plus 5 plus 7 will give you 16 tablecloths. So now you conclude and say that the total number of tablecloths that can be made from the 3 pieces combined is 16. Kindly, are we still on the same page? Are we still on the same page? Okay, so that is how you can attempt such an item. So please take note that they can ask you this same question could hide. This same question could hide part A, and then they want you to find the total number of tablecloths that can be made. So they can hide part A, and then they ask you to find the total number of tablecloths that can be made. Yes, Josh.
Sir,
Mm.
so, sir, I'm having another way of doing that without
Okay.
doing the other. So, sir,
Oh.
after arranging 120, 150, 210 in the
Mm.
columns and rows, those ones. So
Mm.
to get the highest common factor, first of all,
Mm.
I make sure that I get the prime numbers that can divide all of them.
Mm.
The first time I divided by 2 throughout,
Mm.
on 120, 60, on 150, 75, on 210, 105.
Mm.
Next part, I looked for another prime number which can divide all of them, which was 3.
Mm.
So when I divided by 3, I got on one, I got 20, 25, 35.
Mm.
And then for the last time, I divided by 5 throughout.
Mm.
Got 4, 5, 7. So when I do
Mm.
like that, able to
Mm.
identify the highest common factor, which is 2, 3, 2 times 3 times 5, and then
Mm.
the number from each piece. 120, I go to the last number which was down, which was 4. 150,
Mm.
the last number, and then 210, the last number was 7. So that makes it easy.
Okay, good. That one is also very fine. And that is when you're using the prime factors, expressing them in this format. This one is also very okay. You first express it in prime factors, like what he has said. Then you come, you check which number is appearing, that 2 is here, 2 is here, 2 is here. So you take 2 times which other number? 3 is here, 3 is here, 3 is here, times 3. Times, is there any other number? 5 is here, 5 is here, 5 is here, times 5. Then after you multiply, you get the 30. It is very fine. Okay. Okay. And then let me display other numbers that I want us to look at. Go through that. Go through that and tell me which kind of application do you think we are going to look at. Which application are we going to look at? Very good. Yes, so now here you need to know that it is LCM. After getting your LCM, you'll go on and convert that to hours, and then you get the total time. Okay. What about this? Mm, Okay, very good. Now people know that this is HCF. Very good. We read through this now again. Another one. Knowing which application you are going to use is very important. Okay, good. So I think someone wanted us to try the ones of the dates. So allow me that we do go through this of the date. If someone wants to take us through, you can raise up your hand. Oh, but yes, Josh.
Thank you, sir. So Michelle, Joshua, and Zahara, siblings who visited on that day. So Michelle resolved to visit their grandparents every after 4 days, and then Joshua every after 9 days, while Zahara every after 12 days. So from there we get the LC from the LCM, sir. That's the knowledge I'm using.
So you're saying this is application of
LCM.
okay.
So I have 4, 9, and 12. 4, 9, and 12. So at first I divide by 2. On 4 I get 2, 9, and 6. Again by 2, I have a 1, 9, and a 3. Then by 3, I have a 1, 3, and 1. And then by 3, I have a 1, 1, and 1. Yeah. So I get the LCM, which is 2 times 2 times 3 times 3. So that is 36. So those are, so that means Michelle, Joshua, and Zahara will meet again after 36 days. So they last met their grandparents on 1st July 2025. So we need to know July has how many days. Let me see. So July is having 31 days. July is having 31 days. So for me to get the date, since they last met on 1st, I'm going to first of all add the days which complete 30, which reach 31st. So I first add 30 days on the 1st July to get 31st. So from 36, if I remove 30 days, I remain with 6. So that means 6 days enter into another month, which is August. So my date is 6th August 2025.
Okay. I don't know whether Maria has got it. Maria, I don't know whether your question has been answered. Because now when you look at the days here, these days here go beyond the 31. By how many days? Now you look out for how many days enter the next month. But here the problem can only come when you don't know how many months are in July. So when you know that the months of July have 31 days and you need 36. So that is where the problem comes in. But now what you do now, here someone could as well do 36. Remember they last met on the 1st, and then you calculate in that format. So, but you need to know now the months that they can meet again after 36 days. But when they ask for the date, you need now to know under which dates are they going to meet again. Josh?
Sir, I would like to inquire, how can we use the knowledge of finite system?
Finite system. At this level, At this level, we may not encourage you to use the finite because it's not part of the syllabus or part of the applications. So we expect you to use the knowledge of time and timetables.
Oh, okay, sir.
So finite is for primary. But at this level now, we expect you that you have moved a step ahead. So you are going to use your knowledge of time and timetables, but also that you have mastered how the months are the days within the months. Okay. 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 Let me hope anyone with a question on that or in fact, someone was saying that event is for P7. I don't know whether how true that is. I don't know how true that could be. Okay, so you can put in the chat what you want our next discussion to be about. You can place in the chat. Okay, first give me a minute. Give me a minute. Okay, just a minute. Okay, so looking through the chat. Hmm. Okay. Yes, I've seen what we shall be able to try out. People are saying they need us to try something on set theory. So we shall do something on set theory. Then this item that you have sent in the chat, I'm going to, I think when time allows, I will share something by the end of today in case time allows. But if you can, because I'm getting something, it might be around something like around 1:30 approximately, those books. So, but I need to first get time. Those are the total number of books I'm getting roughly. But I think I'm going to get time and then I'll send, in case time allows, I'll send you how to work it out. Yeah. So Marita, I'll send something on the group. Yeah, but it's around 1:30 in that range. Okay. Yes, Josh?
Sir, thank you. Sir, all along I've been wanting to tell you about some concept of rate of work.
Mm.
That concept disturbs me, and I know I'm not alone.
Rate of work, those are proportions.
So I apply knowledge of proportions.
Yes. If it comes to work, when they are saying that the number of people working are four for 1 week, what. But I think we shall get time and then look at ratios and proportions. But I think tomorrow,
Sir,
let's first handle ratios and proportions.
sir,
Then
like,
from ratios and proportions, we shall go on and look at set theory. Yeah.
sir, try to look at the question in CAMSA.
Okay. Now for some of those questions, I think I'll look at CAMSA again. Yeah. But some of them they may not require to use. Some of them may require to use general knowledge. Yeah. Some may require to use general knowledge.
It was talking
Okay.
about machines working for some minutes, then one stopped, then it came back, like it was confusing.
No, that one I think I did it. You check on the YouTube.
No.
You check on the YouTube. That one we did it already. The
Okay,
one
sir.
for the machine working and the rest of that, you can check on YouTube.
Okay, thank you, sir.
Okay. You check CAMSA item 1. I posted it already. Okay. 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 I will alert you. But the moment the lesson ends, I usually upload. Can we have someone to lead us in a closing prayer and pray for us this Sunday? Who's leading us in a word of prayer? Oh, okay, Marita.
Okay. Morning, all of you. Humble yourself to pray. Father, King of Glory, we come into your eyes again, Father. Thank you for the gift of life, for the gift of everything you have enabled us to. Father, King of Glory, please, we need your mercy and blessings in the coming time. Some of us are going tomorrow, others are going today, others are going next week, others are next week. But Father King, please, please protect us, bless us throughout this day and all around. Father, I pray for our teacher, Miss teacher us math, Father King. Please bless him, guide him, and give him whatever he needs, because he's doing this out of your grace, Father King. You enabled him and you guide him every time he comes, Father King. And he teaches things some of us like had not yet mastered and they are hard to us. So we thank him and we thank you for giving us to him and giving us for the King of Glory. Father King of Glory, everyone has their own A's. Me personally want 5 A's and I want an A in math. Father King of Glory. And I know you won't disappoint. And everyone who is here, may he or she get well. And amen. Because they have sacrificed their sleep and everything, their phones, their playing time, all their things, Father. Please give them whatever. Some of us have grown like we are fearing because of our past. But please, this time round, we pray for your courage. As it says in Psalms 73, verse 26, our bodies and our souls may go weak, but your grace is going to make us strong. But I think we pray for wisdom, knowledge, understanding, mercy, and let us stay humble and kind. Let us be listening. Let us be disciplined. Let us be well behaved. Because a person who is disciplined is a person who is a winner. A person who is hardworking is always given. The King of Glory waking up at 5. It's not easy. Waking up at 4:40 is not easy. But because we are hardworking, please see our work, the works of our hands. Yeah, some of us have missed that because of it. So, guide us, please. Just guide us, all of us. Those people who have been attending but they have not, please when them because they have been joining, and those who have been doing their personal in their homes, coaching, please see their works. In Jesus' name I pray. Amen. Thank you, teacher.
Amen.
Okay. Amen.
Bye.
And bye-bye to everyone.